Hi guys, welcome to the last minute statistics live stream. I've planned something a little bit different today. So, seeing as we've got the stats live stream today and the mechanics live stream tomorrow, we'll focus just on statistics today. But I feel like you're probably at the point where you have seen most of these questions before. So, what I've done is I've spent a bit of time writing some of my own questions. And obviously, I've had to put myself in a lot of these questions. So, I've tried to kind of tick off as many of the different things that I think could be coming up in statistics to try and really just have a good broad overview of all of that sort of different skills that there could be. But I'd love to know how things have been going so far. How are people feeling about applied? Are people feeling better about this? Usually people don't like paper three. Usually people spend all of their time on paper one and paper two, and it's at this point that there's like a mad rush for trying to get all of the stuff for paper three done. If you are in that mad rush kind of contingency, I do have some revision sessions. I've probably talked about them before. You've heard of them loads and loads and loads. They're only £15 an hour, reduce the price. You get a 2 hour recording of a revision session with me, plus you get some extra questions and you get some video of me going through those questions too. And if you're interested in that, you can get them in the description. 15 quid for mechanics, 15 quid for stats. Yeah, should just be a no-brainer for some last minute revision for that kind of stuff. Okay. So we're going to dive straight in with some of these different statistics questions. Now, I'm going to just point out I'm not going to be able to cover absolutely everything because there's only 45 minutes for this. Maybe we'll go a little bit over 45 minutes. But we are going to do most of the main things. And when I say main things, obviously I'm thinking about things to do with distributions. So let's have a look at this first question as we go straight into this. And then I'll have a bit of time at the end if anybody's got any questions that they want to talk about. So I've said here, Mr. Bicen found the mean mark of students who did not watch his YouTube videos were normally distributed with a mean of 56.3 marks and standard deviation 14 marks. Okay, so as soon as I personally see something like that, I like to just write down what this means. So if X is going to be the mean mark, I would say that X has a normal distribution with a mean of 56.3 and a standard deviation of 14. So I'll write that with the 14 squared like that, as you know we typically do for a normal distribution like this. And then the first thing it says is to find the proportion of students who did not watch his YouTube videos that scored a mark higher than 65. And it's only one mark, which makes us think this is something that just needs to go straight into the calculator. So we're asking for a proportion, same thing as a probability here. So we're saying, what is the probability that these people, any of these students, scored higher than 65? So I'm saying, what's the probability that X is greater than 65? So I'm just going to show you this in my graphics calculator. Obviously, you would need to know how to do this in your normal calculator as well, but I don't have one of those with me for some reason. So I'll go to my distribution for normal. You could use the distribution mode if you want to, and I'll do the cumulative distribution. I'm going to say that the lower is 65. You remember that you're going to have to put a big value in for the upper value. Sigma is 14, not 14 squared, and mu in this case is 56.3. So we get a probability for this of 0.2672, and that is to 4 decimal places. As long as I've not typed anything crazy in there with that, it looks like I've got the lower right and the upper correct. Yeah, that's all good for this. So that was it getting more than 65 for this. And then I've got some claims here. Obviously, this is the kind of claim I'm going to make. Mr. Bicen claims that the mean mark of students who do watch his YouTube videos is greater than those who do not watch his YouTube videos. A random sample of 50 students who do watch his videos had a mean mark of 60.2 marks. Mr. Bicen assumed that the standard deviation remains 14 marks, and we're going to do a hypothesis test here. It says use a suitable test to assess his claim. You should state your hypotheses clearly and use a 5% level of significance. So often the thing can be quite challenging to work out what it is that they're actually asking for you to do. Once you know what you do just have to kind of like start plugging through those sort of set bits. So this is quite, also I put this as question one, just using the calculator and then doing a hypothesis test for this thing that we've got here. Now you can probably already guess what I think the conclusion is going to be. Do you think I'm really going to write a question that's going to have, I don't know, what kind of conclusion do you think I'm going to have? I'd love to know what you think it's going to be in the chat. So for my null hypothesis here, and I don't know if you remember this, but you can't use the x bar, you have to use the mu symbol. So we're going to say the null hypothesis is that the mean is, as we assumed earlier, that the mean is just 56.3. The alternative hypothesis, which is my belief, Mr. Bicen's belief, is that I think that, what does it say here? It says the mean mark of students do, which is greater than those who do not. So I think that the mean mark is going to be greater than 56.3. And I'm going to jot down a couple of things here. I took a random sample of 50. And when I took that random sample of 50, the mean was 60.2. And you'll notice I've written it as X bar this time. This is because X bar is referring to the mean of the sample, mu is referring to the mean of that whole population of the people who do watch my YouTube videos for this. So I've written down the hypotheses. We're now going to just kind of keep going with the rest of the test. You don't have to write this sentence, but I always write this, that we're going to assume that H naught is true. In other words, we're not going to be saying about the X distribution. We're going to be saying about the mean, the sample mean distribution that we have for this. The sample mean distribution will be normally distributed. We're assuming that H naught is true, so we're going to assume that the mu is still 56.3. But we need to think about differently what's going to happen here. It's not going to be 14 squared for the variance anymore. Hopefully you remember that you also have to divide by the sample size for this, which is 50. So you be really careful when you put this onto your calculator. We're not going to be saying that sigma is 14 squared over 50. We're going to be saying that sigma is the square root of both of those. So it'd be 14 over the square root of 50. Now, the thing that I observed was 60.2. That's higher than 56.3. So I'm interested in finding out what is the probability that that average that I observed was greater than 60.2. And remember, with normal distribution, you don't need to use your equal to sign. It doesn't it doesn't matter with like any kind of it's not going to make a difference if you do or don't do that. So I like to just jot down the things I'm going to be putting in on the calculator. For the upper, I'm going to be putting in a big value. I don't know, like whatever that is, 100,000. For the lower, I'll be putting in 60.2. For my standard deviation, I've already got that written over here. That's going to be 14 over root 50. And for the mean, I'm going to be putting 56.3. I'm just going to calculate that to see what we get for this. So the upper, I've said, is a big number. Well, that's my lower, which is 60.2. My upper is a big number. It's going to be 14 divided by the square root of 50. And we've still got the 56.3. And we have this 0.02443. 0.02443. And you notice that this is less than the significance level, which was 5% in this question. This is less than 5%. So tell me in the chat while I get myself, where did I put my water? Tell me in the chat what that is going to mean about my belief or my suggestion that I think that those who watch my YouTube videos have a higher mark than those who do not watch my YouTube videos. What's that going to tell me? Good. I do have sufficient evidence to reject H naught here. So I'm going to, I have evidence. So there is evidence to reject H naught. In other words, this means Mr. Bicen's belief that those who watch his YouTube videos have a greater mean. So, any questions about these normal hypothesis tests before I move on to the next question here? So, you'll often find in stats, it's often not a lot of stuff to do. It's just about writing things out really carefully. A couple of things I'm going to point out while I just wait for some questions to come through is to put these, whenever you do the null and alternative hypothesis, sometimes people do them with an equal sign. That is completely wrong. They have to be done with colons and they have to be done with mu for this kind of part. And then if they ever ask for a p-value, this thing that we have here, this is the p-value because it's the probability that we're looking for this bit. And so I'm looking at some of the other questions that we've got here. I'm also going to go over some probability kinds of questions as well and some distribution stuff. How do we know how to accept or reject? So what I'm saying here is when I assumed that H naught was true, the probability of this thing occurring, of my 50, the sample of 50 students getting a high mark of 60.2, that probability was very, very low when I assumed that H naught was true. That probability was so low when I assumed that H naught was true that actually I don't think H naught is true. I think that H naught is false, which is why I rejected that thing that we've got there. Okay. Is the p-value the probability times 2? The p-value would be the probability times 2 if we were looking at a two-tailed test. But we're just looking at a one-tailed test for this particular part, okay? So it's only, you double the p-value if it's a two-tailed test. I think that came up, I think, in the 2023 paper, or maybe it was before that. And yes, you can do these tests using z-tests if you want to. You can do it using critical regions. You don't have to do it using all of this stuff. You'll often see in a mark scheme, they'll be talking about z values, and that's where you subtract the mean and divide by the standard deviation, okay? So I'm going to look at the next question that we've got. I don't have a mark scheme for this because I obviously made these up. And I'm obviously going to be doing it about things that I'm interested in. I mean, I can't even think what this is really going to be about in a game of Zelda, but obviously, if you don't know by now, I'm a big Nintendo fan. In particular, I love The Legend of Zelda, and Tears of the Kingdom has drained a lot of my hours away. Even though the last few days it's all been further stats and decision and things like that. Anyway, let's have a look at this question and see if we can identify what kind of distribution is that we've got here. So it says Mr. Bison is playing a mini game in the Nintendo video game The Legend of Zelda Tears of the Kingdom and finds that he wins a prize with probability 0.3. This is not what I actually do. I'm just trying to take the mickey out of how ridiculous stats questions are. Because who's going to decide to play the game 30 times and like fix it at playing 30 times? That's just not how we do things. But for this stats question, we've made it up. This is actually how we're going to do this. And I will be answering the questions about Tears of the Kingdom being better than Breath of the Wild after this question. So, write down the name of the distribution that can be used to model the number of prizes that he wins, state an assumption that must be made for this distribution to be used. So, I could say that if we let X be the number of prizes, 1, and you don't ever have to write down that sentence. I just do it because I think it makes it easier to kind of communicate. Then we know that X would have a binomial distribution where we're playing the game 30 times and there are 0.3 that we have here. Now, if you didn't write it like this, if you wrote down binomial, you would still get the 1 mark for that part. But they did actually say state an assumption that must be made for this distribution to be used. Now, we're already playing the game 30 times, so I shouldn't talk about a fixed number of trials because that's kind of obvious that that's happening. But I think we should talk about the fact that the probability should be fixed. Or we could talk about that each time I play the game is independent. So I'm probably going to go with the independent one here. State an assumption that must be made for this distribution to be used. The chance of winning in one game is independent of the other games. If you just wrote something about the trials are independent, that would be fine. So just thinking about those things that we have for binomial that we have. So part B, it says just calculate the probability that Mr. Bison wins exactly 10 prizes. In other words, we're trying to say, because I said that X is the number of prizes one, it helps me remember that it's just saying probability that X is equal to 10. So if we're talking about X being equal to 10, we're going to jump to binomial this time. And the choice is between PD and CD. Now, I have the graphics calculator, so I can do it in cumulative. And I will just say that the lower and the upper are both 10. But if you don't, you would go to the binomial and you would do PD and say that X was 10. We're doing 30 trials and the probability is 0.3. And we get 0.1416, 0.1416 to 4 decimal places for this question. And then part C of the question, find the probability that Mr. Bison wins at least 7 prizes. So that means at least 7 is greater than or equal to 7 that we have. Now, because some of you may not have the graphics, on the graphics you could just do it between 7 and 30. Greater than or equal to 7 means that I'm doing 7, 8, 9, all the way up to 30. So I'm removing all of those ones that's underneath it, which is 1 minus the probability that X is less than or equal to 6, because all of these ones down here are less than or equal to 6. So that's how you could do it with the graphics. The non-graphics, you would put in 6 and lower, and you'd subtract that from 1. But because I have the graphics calculator, I'm just going to go straight in to the binomial CD. I'm going to say that my lower is 7, the upper is 30 because I'm playing 30 games, and it will just give me this one straight away like this. It will just give me my 0.8405 that we have, okay? So we have 0.8405. And again, that's just 4 decimal places. So this is pretty straightforward binomial that we've got here, but this is where I want to read a little bit more carefully what's going to happen in part D. And see if you can tell me what's going to happen in part D so I can have a look at the chat. What is different about part D here? So it says, Mr. Bison decides to play the minigame 30 times every day for 2 weeks. And this is where it just feels kind of silly. Like no one ever does this stuff in real life, but I made up a question to try and match the kinds of ridiculous things that they ask here. And I'm seeing it in the chat already. This is a double binomial. This is a binomial within a binomial, because I'm now doing this set of 30 games, which we've been talking about here, but I'm doing that for 14 days for those 2 weeks that we've got here. So if I'm going to say, let Y be the number of days, because I should read question D. It says, calculate the probability that Mr. Bison wins at least 7 prizes every day. Let Y be the number of days where Mr. Bison wins at least 7 prizes, we now have a new binomial where y has a binomial distribution, but there are 14 things this time because we're now doing this for 14 days, 2 weeks. And the probability that I win at least 7 prizes, we've just worked out in the previous part of the question, which is 0.8405. And you can just use that to 4 decimal places. And then part D, it says calculate the probability that Mr. Bicen wins at least 7 prizes every day. In other words, the probability that y is equal to 14. Now, you can actually do this without having to use the distribution mode. I'd like to know what kind of calculation using 0.8405 could I do to calculate it being, winning at least 7 prizes on all 14 days. What is that I would be able to type in if I wasn't going to use the distribution mode or the distribution part of the stats thing? Good. I'm seeing it in the chat. You can just do this as 0.8405 to the power of 14 because we want that to be the same every single day. So I'm just going to quickly do this on this calculator, 0.8405 to the power of 14. So the answer is this, which is 0.0878 to 4 decimal places. But just to show you how this works on the other calculator, if I do have it as binomial, I'm going to say 14, 14, and 14, and 0.8405. And we do get that same probability of that 0.0878 for this. Okay, and then part E of the question, it says calculate the probability that Mr. Bison wins at least 7 prizes on at most 10 days of the 2 week period. Now, at most 10 days means that y has got to be less than or equal to 10. So I'm going to go and use the cumulative mode on the calculator this time. And I'm going to be saying at most 10 means between 0 and 10. And we get 0.1727. So that is 0.1727 to 4 decimal places. So this was an example of a binomial within a binomial, but this is not the end of the question because, of course, I wanted there to be some extra part to this question too. So it now says, after playing the game so many times, Mr. Bison believes his skill level has increased and claims that his chances of winning a prize are now increased. So I've played it so much because I was playing it, 30 times a day for 14 days. 30 times 14. I've played this game 420 times. I think I've got better at the game. He decides to play a final set of 50 games and he wins a prize 20 times. Test Mr. Bison's claim at the 5% significance level, stating your hypotheses clearly and stating your p-value. So this is going to be a hypothesis test for binomial that we've got here. And we are talking about the original kind of thing. So we're going to be saying that it's a binomial distribution where we're doing it 50 times and we have the probability p that we've got. You could put that p in as 0.3, but the null hypothesis is that it's still a 30% chance of winning. The alternative hypothesis is that it's greater than 0.3 because my belief is that I've got better at playing the game. If it had said Mr. Bison believes that his chance of playing the game has changed, we would write it as not equal to 0.3 and it becomes a two-tailed test instead. So you don't have to write the sentence, but I always do it. Assume that H naught is true. In other words, P equals 0.3, which means that X has a binomial distribution with 50 and 0.3. And then people get confused about which thing I should test. I have won the game 20 times. That's more than you would expect, okay? If it's 50 and 0.3, 50 times 0.3 is 15. I would expect to win it 15 times, but I've won it 20. So I'm going to say, what's the probability that I win the game 20 or more times? Or more, because if I won it 21 or 22 or 23, all of those things would contribute to me making me think that the probability was greater than 0.3. So if you were going to do that on your non-graphics calculator, you would do 1 minus the probability that x is less than or equal to 19. But to save us a bit of time, I will go straight in with this version. You just need to make sure that we do switch around so that we have the correct number of trials. The number of trials is back to being 50 and 0.3 for the probability. And we are saying that it's greater than or equal to 20. So in other words, up to 20 to 30. And that probability is 0.084784799, which is greater than 0.05. So tell me in the chat, what does this mean about me playing a mini game in The Legend of Zelda Tears of the Kingdom? Have I got better at playing this game or not, is what I'd like to know. Oh, yep. It is. It's 20 to 50. You're right. So it actually doesn't change it very much at all, but it should be 20 to 50, and it's 0. 0.0848. So it doesn't actually change it very much. Yep, so I'm going to accept the null hypothesis. You can write it either as accept or accept the null hypothesis, say there's not enough evidence to reject it. So I'm just going to say not enough evidence to reject H naught. Mr. Bicen has not increased his chances of winning. In other words, in those 50 trials, I probably was just getting a bit lucky. So I hadn't done enough to actually improve that. Now, online answers, I think Breath of the Wild is better than Tears of the Kingdom. However, I love them both. Many an hour in winter spent going through those kinds of playing Nintendo, and I miss it already. Okay, so that was the one that I've gotten some binomial stuff. We're now going to have a look at a question that I hope won't be too triggering, but it's about exams. Of course, it had to be something to do with exams that we've got here. So, Mr. Bicen is analysing the time spent by students on a question worth 18 marks in their statistics exam. I really hope there won't be an 18-mark question in Thursday's exam, but if there is, it might be me that's kind of brought it on with a bit of this karma here. Anyway, he knows that these times can be modelled by a normal distribution with a mean of 22 minutes. So for question 3, if I'm going to say that x is the time spent on the question, we know something. We know that x has a normal distribution with a mean of 22, but it's weird. They don't mention anything about the standard deviation or the variance here. So I'm just going to write it in like this. And in my mind, I'm thinking that's odd that they haven't told me about the standard deviation that we've got here. So yeah, actually, there was 18 marks in the further stats exam. That's probably why I wrote this question. I was kind of triggered by that horrible last question 7 that we had. So I'm already thinking that I don't have this, and I'm thinking I'm probably going to need to work this out at some point in the question. Let's now actually read what it says in part A. It says, given that 6.68% of students spent at least 28 minutes on the question, that's too long to spend on an 18-mark question, by the way. Find the probability that a randomly selected student spent less than 15 minutes on the question. Sorry for the typo. It should say randomly selected rather than randomly select. So I'm just going to write down that statement. It says the probability that 6.68% of students spent at least 28 minutes. So that means the probability that x is greater than 28, don't worry about the or equal to sign, is equal to 0.0668. Now, I can't type anything into the calculator for the thing that they're looking for, because the thing I want to find later on in the question, which I'm going to write down here, I want to find the probability that a randomly selected student spent less than 15 minutes on the question. But how can I type that in? Because I don't know what the standard deviation is. So my first thing I need to do is I need to find out what the standard deviation is. And the way that we're going to do this is we do this process where we standardize. Now, it's not standardizing because we're doing the standard deviation, but we're going to standardize it to Z, which has the normal distribution with a mean of 0 and a standard deviation of 1. So I'm going to do this on my calculator. I'm going to find out the probability that Z is greater than something is 0.0668. And to do this is where you're going to have to use the inverse normal, which I'm seeing people talking about in the chat as well, because we're trying to find out what is that value of Z. Visually, what we're talking about here is we're saying the value that Z, this thing that I want to find where that question mark is, the area is 0.668. I want to find out what that value is, knowing that the mean is 0. And then I could do some standardizing process in just a second. So I'll go to my normal and I'll do the inverse normal. You can see, because I'm wanting Z to be greater than a particular value, I'm going to put the tail to the right. If your calculator only does the tail to the left, you would have to work out what this area is by doing 1 minus 0.0668. But I'm going to do the tail on the right. I'm going to say that the area is 0.0668. The standard deviation is 1 and the mean is 0. So the value of Z that we have here is 1.500. That's fine, just to that many decimal places. So I'm going from the X to the Z, and I'm going from the 28 to the 1.50. So I know to do this process, you take the X value, you then subtract the mean and you divide by the standard deviation, and that is what the Z value is. So I'm just going to do that process over here. I'm going to take the X value, which is 28. I'm going to subtract the mean, which is 22. and I'm going to divide by the standard deviation, and that gives me the z value. Notice how this is the z value, the 1.5, the mean is the 22, and the standard deviation is the thing that I don't know. So my calculator's over here. I'm just going to do the 28 minus 22, which is obviously 6. So I now have that 6 over sigma. 6 over sigma is 1.5. So I'll do 6 divided by 1.5, and I get that the standard deviation is 4. So I now know that the value of the standard deviation is 4, which means I can actually complete this question because I now know that the standard deviation is 4 and the mean is 22. So I'm going to go back to the normal, not the inverse normal. And I'm going to do the cumulative one. I want it to be less than 15. So I'll put a very negative value down here. I'm going to say 15 is the upper, sigma is 4, and mu was 22. And the probability I get is 0.0401, and that is to 4 decimal places in this particular question. Okay. So this actually probably, when I've seen this question before, this is only 3 marks, okay? They give you 1 mark for this and 2 mark for the standardizing process. So this is not, this is the standard amount of things that we get here, okay? I checked this with mark schemes to try and make these marks feel as like realistic to what they've been, and a standardizing question that was just like this was worth 3 marks, believe it or not. Okay, and then we've got a big clue in the question because they're telling us that they want us to have a normal approximation. It says for a different question worth 8 marks, so it's a different question, 55% of students spent at least 9 minutes on the question. A random sample of 300 students is taken. Using a normal approximation, find the probability that at least half of these students spent at least 9 minutes on the question. So it's not really to do with the normal distribution to begin with. It's going to start off as a binomial because we are taking a sample of 300 students, and the probability that they spent at least 19 minutes is 0.55. Now, I can actually do a normal approximation here, and I'd like to know in the chat why I can do a normal approximation for this one while I just start writing out the next part. So I'm saying this is going to become a normal distribution. Now, if you can't remember these are actually hidden somewhere in the formula book in the further stats bit. But if I want to find out this value, this is found by doing NP, and then this one is found by doing NP 1 minus P. Good. N is large and P is close to 0.5 in this question. So I'm going to do NP, which is 300 times by 0.55. That's 165. And then for this one, I'm going to do NP, which I've already got on my calculator as 165. I'm going to multiply it by 1 minus 0.55, and I get 74.25. So this is 74.25. Now remember, that is the variance. So when I do sigma, I'm going to do the square root of 74.25. Now the question said, find the probability that at least half of these students. So I'm actually looking for the probability that X is at least 150. But because we're doing it as a normal distribution, we're going to have to change this slightly differently. So greater than or equal to 150 should be what? What's going to be happening in this part? So I'm going to just actually, whilst people are talking about that, I'm going to see if I can show you where the NP 1 minus P is in the formula book. So if you go to the further stats bit, this is on page 13. This is in the further statistics part. It does actually say that you have the mean is NP and the variance is NP 1 minus P. So that's allowing you to kind of go across to finding the mean and the variance for it as well. And everyone's told me it's 149.5 because we're doing a continuity correction here. So I hope I can squeeze this all on the same page. I'm going to be doing my normal. So distribution normal cumulative, we're saying that it's greater than 149.5. So I'll put a big value at the top. Sigma is the square root of 74.25. So it's the square root of 74.25. And the mu is 165. And we get 0.9640. I think that looks fine. That looks quite high though, doesn't it? Did I type everything incorrect? 149.5 up to this. Sigma was the square root of 74.25 and 165. That's all right. Yeah. It should always say stating using a normal approximation for this bit. It should always use the word approximation if it wants you to do this, okay? So, yeah, just sometimes I always just think if you see a probability like, whoa, that's a bit high or that's a bit low, it's always just worth double checking the numbers that you've got to see if everything makes sense, okay? So we've done a few different things just to kind of go back through these. We did in question 1 was just like a standard finding a probability. Question 1B was a normal hypothesis test. Make sure you know how to do that skill. In question 2, we did binomial, and then we did binomial within binomial, and then we did a hypothesis test with binomial. Question 3, we've done one where you had a missing sigma. If you had a missing mu, it would follow the same process. And if you had missing both of them, you would come up with 2 equations like this bit and you'd solve them simultaneously. And we've now also done a question with a normal approximation as well. So I now have my favorite, and I don't know if you can hear my sarcasm here, but my favorite part of all of A-level maths is, of course, the large data set that we've got. So this won't take long to do this, and then we'll try a couple of questions that I haven't written that I've found as well. So Mr. Bicen loves the large data set and has spent all day analyzing if there is a correlation between daily mean pressure and daily total sunshine at Luchars. Tell me where Luchars is. Tell me where Luchars is in the large data set. Where is it geographically? Because that's usually quite useful to know that kind of stuff. He calculates the product moment correlation coefficient between these two variables for a random sample of 20 days and obtains that R is 0.552. Good. Seeing everybody saying it's at the very top, north, Scotland. So you think up north, colder, rainier, more sunshine during the summer, less sunshine during the winter, like that kind of stuff. Okay. I'm also going to cram my, if you haven't seen my large data set video, put it on 2x speed. You don't need to watch the second half of it where I do the questions. Just watch that literally moments before you go into the exam. You'll be made up and done. There's nothing else that you really need, I don't think. So we're going to carry out another hypothesis test. We're going to carry out a suitable test to investigate Mr. Bison's belief at a 1% level of significance. State clearly your hypotheses and your critical value. Now, the thing I want to know from you guys is, what is my alternative hypothesis going to be? And I can't wait to see in the chat what my alternative hypothesis is going to be. Yeah, you can always use, to Ivan, you can always use the Z coding if you need to, okay? So I'm seeing a lot of different, I'm seeing a couple of different things so far. I've seen somebody saying that it's two-tailed, somebody saying that P is greater than equal to, P is greater than 0, or rho is greater than 0. Good. It's rho is not 0, because if you look at what's actually worded in the question, it says that I am investigating if there is a correlation between them. I didn't say that there is positive or negative, and you cannot use R. It's incorrect in the video that I made for everything to memorize for statistics, but it's correct in the PDF. Rho is equal to 0. The alternative is that rho is not equal to 0. If you do it as a P, it doesn't matter. It's absolutely fine. So instead of using 1%, I'm going to half it. So in each tail, it's not going to be 1%, it's going to be 0.5%, which is 0.005. Do not get that bit wrong. So I'm now going to find my critical value. My critical value, the observed value is that R is 0.552. Formula books down here. It's the correlation coefficients page. I've been doing further stats too today, and we have to do this quite a lot. And the sample size in this question, I probably should have jotted it down, but it's 20 days. So I'm going to go down to 20, and I'm going to get this value here. And the reason I designed this question is because if you did it a one-tailed test and a two-tailed test, you get a different conclusion. So the critical value is 0.5614. So the critical value is 0.5614. Now, what does this tell us? Are we going to accept the null, or are we going to reject the null for this? No, I've had that formula book for ages from as a teacher. I probably took it from somewhere maybe I wasn't supposed to, but I've got it. Yeah, good. So I'm actually going to accept this because my critical value is this, and my observed value, 0.552, is less than 0.5614. So there is not enough evidence. There is not enough evidence to reject H naught. There is no correlation. There is no correlation. Because if you think about what's going on here, we're saying that the value of this, of R, the higher it is, the closer to 1, the stronger the correlation. This is the threshold. We're saying if it is stronger than 0.5614, then there is correlation. But our one is not stronger than 0.5614. So it's not strong enough to suggest that there actually is correlation that we've got here. And you can always think about it as the magnitude. If the magnitude of this number is smaller than this, then it is not significant, because sometimes there might be things with negatives as well. And then part B of the question we have, this is the stuff I'm dreading. This is the stuff I just, because I'm trying to get all of it correct when I do the exam, this is the stuff I don't want to come across. Mr. Bicen continued his investigation looking at two variables and the same sample of 20 days. I want to know in the chat what you think for this one. He calculated a value of R as 0.842 for these two variables. So that's pretty strong, right? That's a lot stronger than we've got here. So we're talking about things that have a positive correlation. Given that one of the variables was the daily mean temperature, suggest what the other variable could be, giving its units. Now, personally, I'm going to pick something that I know the units for, and hopefully before the exam, you'll watch my large data set video, or at least the PDF of it, and you'll be like, cool, I know what to do for this. So there should be positive correlation here. Now, positive correlation, I'm seeing lots of people suggesting this. I would probably go with sunshine. I would probably go for the daily, or the, what is it, total hours of sunshine. It's the daily hours of sunshine. Daily hours of sunshine. And the reason I'm going to go for this one is because there should be positive correlation. If one of the things is temperature, the more sunshine, the higher the temperature. That kind of makes sense. So this is the daily hours of sunshine, and the units is hours. Now, there are some other things that they would probably accept for this. Probably would accept pressure. Okay, so pressure, the daily mean pressure, and I think that's measured in hectopascals, which is HPA. That would probably be expected because usually higher temperature correlates to higher pressure. I'm trying to think of some other things that they could do. Higher temperature could be with I had loads more than that. Probably pressure and sunshine are the ones that I'd be thinking about this part, okay? You could do humidity. I think humidity could be doable as well. Basically, just have a go at guessing something, but try and just go for the obvious ones. And just before you go in the exam, have a brief look at the kinds of values of stuff that you might be expecting as well. So those are the questions I've written. We do have time to do a few more. Now, I just must give you a little bit of a warning about these questions. These questions are taken from the international A level, where they are way more generous with the marks that they've got. So this question would not be worth this many marks, okay? But it is quite a challenging one, which is I selected it for this reason. So there's two parts. There's part one and part two that are completely unrelated to each other. I'm going to draw the Venn diagram again, just so we can have it to refer to and I can draw things over the top. So we've got A and B. There's my A and B, and just I'll do these in a different color. We have P, Q, R, and S. And then everything looks pretty straightforward to begin with because they tell us the probability of A is 7/25. Now, when it's over 25 and 5, I just prefer it as a decimal. And obviously 7/25 is 0.28, okay? 7/25 is 0.28. So the probability of A, which is P and Q, P plus Q is 0.28. That's that first thing they've told us. They've also told me that the probability of B is 1/5 or 0.2. So the probability of B is Q plus R, which is 0.2. And then they've got this more crazy kind of bit that they're telling us about. Now, do I have my highlighter? Yes, let me grab this here. So we're talking about the probability that these things match. We have the probability of A and not B, or not A and B, is equal to 8/25, which is 0.32. I know that's gone slightly off the page, so I'm just going to write this underneath, which is 0.32 that we've got here. And I'm going to explain in a second what it means in general when a circle is contained fully inside another circle. Actually, I can explain that really quickly. It's a really good question. If you had a circle and another circle inside it, it just means that this part, whatever's inside this bit, is always going to be a part of the other set. Okay, there's no other way that if that thing has occurred, then the other part has occurred as well. Okay, so we're now going to look at these bits, and I'm going to start off by highlighting them. A and not B. A and not B is this section, okay? And then the other part, because it says or, you're literally just going to highlight both of these things, which is not A and B. The thing that's not A and B is this section. And because there's the or on the in-between here, the or means you're literally just going to have both those things that have been highlighted. So I'm going to say that P plus R is equal to 0.32. And they've given us all of the information. There's nothing more to do. They've just said use algebra to show that 2P plus 2Q plus 2R is 4/5. Now, I don't know if you can spot this, but look, I have a P and a P. I have a Q and a Q, and I have an R and an R. So what's going to be the best way of trying to find 2P and 2Q and 2R here? There's a really simple way of doing this. And it is, I guess, in a way to do with simultaneous, but I'm actually just trying to say, how can I quickly come up with 2P, 2Q, 2R? Yeah, very good. I've just seen a few people saying this in the chat. I'm just going to add these together. So if I add all three of these equations, I get 2P, 2Q, and 2R. And if I add these things here, that's 0.48, 0.5, 0.8, and 0.8 is 4/5. So pretty straightforward for that bit. But it wouldn't be worth 4 marks, okay? Not in our paper. This is from an international paper where they, for some reason, give out marks more readily. And then it says find the value of P, the value of Q, the value of R, and the value of S. So we'd kind of forgotten about that value of S. Now, this means that P plus Q plus R, this is equal to 0.8. So P plus Q plus R is therefore 0.4. I've halved it so that I've got to this stage. So that means that all of this part here is 0.4. And I love having a Venn diagram to kind of refer back to stuff, which means that the S must be 0.6. So S must be equal to 0.6 so that the whole thing adds up to 1 for this. The next thing I need to do is to find P, Q, R, and S. Okay, well, I know loads of facts now. I know that the P plus Q is 0.28. So 0.28 plus R is 0.4. So R is 0.4 minus 0.28. 0.4 minus 0.28 is 0.12. And I also know that Q plus R is 0.2. So P plus 0.2 is 0.4. Well, that means that P is therefore equal to 0.2. And then my last one is that the P plus the R is 0.32. So that's 0.32 plus Q is that what I've just said? Yeah, the P plus R is 0.32, and that is also equal to 0.4. So Q is 0.08. So I've got those values there. There is no way that would be worth 5 marks in our one that we've got. Okay. And then the next part of the question is unrelated. Okay. So it's to do with Venn diagrams, but it's not the same Venn diagram that we've got. Really weird question. So I thought this was a great one to have a look at. Two events, C and D, are such that the probability of C is x over x plus 5, and the probability of D is 5 over x. And they do give you a nice kind of clue of what to do. Oh, sorry, I should say it says where x is a positive constant. By considering P of C plus P of D, show that C and D cannot be mutually exclusive. Well, let's add the probability of C and the probability of D like they told us to do. That's x over x plus 5 plus 5 over x. They're going to need a common denominator. So this needs to be multiplied by x on the top and bottom. That's x squared, x plus 5. This is going to need an x plus 5. So it's going to be an x plus 5 and an x plus 5. So we have for the numerator x squared plus 5x plus 25. And the denominator is x plus 5, which is x squared plus 5x. Now, what do I know about the thing on the right-hand side if x is a positive constant? There is something I know about the probability of C and the probability of D that I've got here. These don't, the x plus 5s won't cancel or anything. This is a really tricky question to kind of think about what might be happening here. Good, lots of people are saying it is greater than 1. So we can say x squared plus 5x plus 25 is clearly greater than x squared plus 5x. So the probability of C plus the probability of D is greater than 1. Now, if they were mutually exclusive, then the probability of C plus the probability of D is the same as the probability of C or D. That's just the definition of when you have things that are mutually exclusive. The probability of this plus the probability of this is the probability of the OR. But probability of C plus the probability of D is greater than 1, which isn't possible for probabilities, for the probability of CUD. So they are not mutually exclusive. I know I've gone off the page a bit. So they are not mutually exclusive. It's a bit like when you have, I don't know, like a contradiction here. It doesn't really make any sense that if they are mutually exclusive, then we're saying the probability of either of them happening is more than one, which is not possible for things that are mutually exclusive. Two things that are mutually exclusive have got to be kind of less than one, like that. Okay. You could do this as like a test for independence if you wanted to, but I don't know. I think this is the way that they've asked us to do it, with like adding them together, and really just a bit of algebra there. Now, I probably will run over just by a few minutes. There's the mark scheme if you do want to go through this afterwards. But I'm just going to do this last question. There is no way they would give out this many marks. And we're just going to go a couple more minutes over. So I like this one because we've got some more normal distribution stuff here. The weights of packages arriving at a factory. I'm going to use the letter W. The weights of packages are normally distributed with a mean of 18 and a standard deviation of 5.4. Find the probability that a randomly selected package weighs less than 10. This is 3 marks? No way. In our spec, this is 1 mark. So we want to find out the probability the package weighs less than 10. Nice, easy one for us to finish off. So I'll do a very negative number, 10. Sigma is 5.4, and mu is 18. 0.0692. Okay, part B. The heaviest 15% of the packages are moved around the factory by Jemima using a forklift truck. Find the weight in kilograms of the lightest of these packages that Jemima will move. So we know the probability or the proportion of packages which weigh greater than some particular value, which I'm going to just call A, is 0.15. We're saying the probability, if it's greater than this value, that's 15% of them that are going to be moved around the factory. So the way I'm going to find this is by doing my inverse normal. And I don't need to do any standardizing because I know what mu and sigma are. So I'm going to do my normal inverse. The area is going to be on the right, 0.15. And I've got that sigma is 5.4 and the 18 from before. And we get that the A value is 23.6 kilograms rounded to 3 significant figures. So the lightest one that Jemima will move will be 23.6 kilograms for this one, okay? If you were doing it the area the other way around, you would say that the tail was on the left, and instead of 0.15, you'd do 0.85 instead, because 1 minus 0.15 is this, is 0.85. It says one of the packages not moved by Jemima is selected at random. Okay, find the probability that it weighs more than 18. So I want to find the probability that the package weighs more than 18, but it says that it's one of the packages not moved by Jemima. Now, if it's moved by Jemima, it's this. Jemima does ones that are greater than 23.6. So if it's not Jemima, it'll be less than 23.6. So this is a given that probability. This is a conditional probability. We're saying what's the probability that the weight is greater than 18, given that the weight is less than 23.6. So I wanted to get this one in here as well. Now, you know how you do these calculations. This is the probability that it is both of these things that are true. So it's got to be greater than 18 and less than 23.6. This is because I'm doing the probability of A given B is the probability of A and B divided by the probability of B. If it's greater than 18 and less than 23.6, I can write that as one single thing instead of like that. And I'm going to divide it by the probability of B. The probability of B is this part, the probability that W is less than 23.6. Now we actually know the probability that W is less than 23.6 must be the 0.85 because more than 23.6 was 0.15. So what I'm going to do is put that part of my calculator, which is that it's between the 18 and the 23.6, and that's 0.3501407, and I'll divide that by 0.85. 0.3501407 divided by 0.85, and it's 0.4119, and that's to 4 decimal places. And then to finish off, our last question says, a delivery of 4 packages is made to the factory. The weights of the packages are independent. Find the probability that exactly 2 of them will be moved by Jemima. Now, to be moved by Jemima is 15%. Moved by Jemima. Remember that is 15%. So we've got 4 packages. You can either do this using a binomial, or you could do it in a sort of longer kind of way, but I'm going to say this is going to be that we have got a binomial distribution because there are 4 packages coming to the factory, and 0.15 of them are going to be moved by Jemima, and we're going to find the probability that x is equal to 2. Okay, so we will do this very, very quickly. Binomial, so it's a binomial within a normal question, and we are going to say, oh, it's just a PD, isn't it? So we're doing 4 of them, and the probability is 0.15, and we get 0.0975 to 4 decimal places for this part, okay? So let's just double check that we do have this correct. We do have the 0.975, the 0.142, the 23.6. Yeah, got all of that correct. So we did go 5 minutes over here, but I'm now going to have a quick look through the chat and I'll see if there's any questions that I can answer. Like I said, if you do want like a slightly longer kind of version of this, you can get the recording immediately, 15 quid. Make sure that you check your spam if you do order it, because the confirmation email, some people it's been going into their spam. You should have the confirmation email within a few minutes of purchasing it. And you've got that for mechanics and for stats as well. I usually leave all my answers to 4 decimal places for stats, but on the front of the paper, it does say 3 significant figures. So I don't know, we should probably, I do go with 4 decimal places. You don't get kind of punished for that though. So this paper was from an international paper. I can't remember which paper it was. I didn't write that down. In terms of my best tips for my CG50, I do actually have a video of me going through that. It looks like a long video, but the CG50 is only the first part of this bit as well. Don't really like to comment too much on boundary predictions just because anything can happen. And I just think just do your very, very best for this kind of stuff. And then, yeah, that's all you can do is just do your best and just see what happens with it. Can I do the normal question about the doctor appointment times? I'm afraid I don't have the time to do that now because I do need to get wrapped up at the end of this bit. What are the ones have I got here? Biggest tips for stats is that you'll find there's not actually much work that needs to be done. So don't rush into a question, pause and think, what's the distribution? What am I doing here? And then go through it. It's the same with mechanics as well. It's not like pure where there's loads and loads of stuff to do. It's about pausing at the beginning and thinking, what's my strategy going to be for this? Yeah, when it says it's independent, it meant that we could use binomial for that last question because each package, we've got 4 packages, fixed number of trials, fixed probability of 0.15, independent, all of that sort of stuff. What else have I got down here? I am doing a mechanics stream. I'm doing a mechanics stream tomorrow. Again, I'm going to try and find questions that you haven't seen before for this sort of stuff. What else have I got here? In the exam, do you think rewriting bits of the question helps or is a waste of time? I personally still write stuff out like this. I like to look at all of my own written text and then look back at the main question if I need to. I way prefer to look at my own writing and then I think, oh, I wonder if there's anything else that I need. So I go and look back at the question. What else have we got here? I'm just going to answer a couple more questions. The large data set. Yeah, it's not many marks. However, at this stage, if you just want to like do a last minute push on the large data set by watching like a 15-minute video at 2 times speed, it could be the difference between you getting 2 extra marks that could push you over a grade boundary. So I hate the large data set, but it is worth just having some of that stuff fresh in your mind here. What else have we got? How do I stop making silly mistakes in calculations? I mean, I know I keep making mistakes with typing things in my calculator for further stats too. So I know I'm going to be checking it twice if I have the time to do it. Otherwise, it's about not rushing into a question too quickly. It's about being a little bit slower with these kinds of things. Okay, it's about really, not rushing into a question too much. What is the underlined thing in section A? I'm not sure what that is. Okay. Timing should depend on the marks in some ways, but I like to try and go as fast as I can in the early questions so that I have more time for the more challenging questions. So, it's not all, it is rough guide of 1.2 minutes per mark. However, you obviously want to buy yourself as much free time as possible at the end of the exam. Okay. In terms of how long to spend on stats and mechanics, you've got to make that decision. You've got to decide where do you want to put your focus? Where's your weaker area? Do you want more time on your weaker area? Do you want more time on your stronger area to make sure that it's perfect? Lots and lots of different things with it. Do I start with stats and mechanics? I'll probably start with stats because I know that mechanics is probably my strongest part of like all of maths. So yeah, come along to my mechanics live stream tomorrow. I'll be picking some questions that we'll go through another 45 minutes on that. Like I said, if you do want to get any of the tickets to the other sessions, literally, you could download it now. Not even download it, you could get the ticket now and it'll be in your inbox and you can use it tonight. Anyway, I'm going to wrap this up here. So thank you guys so much for coming along to the live stream. And I hope I will see you tomorrow for the mechanics one. I hope you found this useful. Yeah, and just good luck if anybody's got an exam tomorrow. I've got further pure one, so I need to go and do a last bit of looking over some of those things. And I will do a quick reaction to further pure one on YouTube Shorts. Okay, guys, have a great evening, and I will see you soon. Bye, guys.